We're going to continue our look at the SIPART electro-pneumatic valve positioner with built-in pressure sensors and the extra diagnostic functionality that these give you, including advanced leakage detection. So we can see here from the trend, I'm just going to change this to a strip and speed it up. I have the valve set point at 100% and the actual value at 100.1 or 100, so everything's fine there. And I'm going to have a look at the maintenance and diagnostic settings now for pressure monitoring. So what you can see here is we've got the pressure monitoring turned on and the units is bar, and then we're looking here at the hysteresis. The PZ is the pressure coming into the valve positioner. So I've set some limits up there, a minimum of 3 bar, maximum of 7, and then you can tell the valve positioner what to do. So on this one it's fail-safe hold, so it will hold it in that position until it rectifies itself. So that's one option. And then on the output of the pressure transmitter, you'll see here the Y1 option. I have a maximum pressure, so we don't really want to be pushing too much pressure into the valve diaphragm, so we can alarm on that to stop it from happening. And then we have this value here, limit for leakage in your units, so bar per minute. There's a little bit of a mistake here, it should say bar per minute at the end. So if I have a leakage, it's actually monitoring the flow rate of that leakage, and then that will trigger a leakage alarm. But more importantly, what you'll see on the graph here is it will try and control that back to where it should be. So the actual control of the leakage is much better on this valve positioner. So I'm going to induce a leakage alarm now, and we'll see what happens. So what you'll see on your real-time values here is your pressure dropping. It takes a little bit of time to calculate the leakage. I'm still controlling okay. It's a very small leak that I've simulated on my valve. So you can just see there on the trend, this is where pressure in the valve diaphragm has dropped to a state where now it has been unable to control. I can see my leakage value there, and it's brought it back and it's controlling it quite nicely at that set point. So if I just update my diagnostics, and you can see here now that I have a maintenance request. And if we have a look at the actual alarm, you can see here leakage limit exceeded, possible causes defective actuator membrane, leaking air supply. So it's telling you exactly what's wrong with it. The diagnostics is there. Now the trick to this is, this took me a little bit of finding. If I correct my leak, this alarm is still latched on the PS2, so we need to clear that. So to do that, if we go to device, maintenance, and you can see down here diagnostic values, then you can see the leakage value which has been latched, and until we clear that, I can't clear the leakage alarm. Okay, so even if I mechanically fix the leak, I need to clear that here. So we can just reset the peak values. and you can see there my leakage has now gone back down to 0. So there you have it. We still have the old-fashioned way of monitoring leakage because the PS2 doesn't bleed any air at a steady state position, but of course that could be that down to excessive vibration, so it's looking for deviation from set point in a simplistic way, and this really just backs that up by monitoring the pressure. So we can see that the pressure is leaking from the diaphragm on the valve, and there's no guesswork involved. So there you have it, a quick look at the new PS2 with built-in pressure sensors and the extra diagnostics that you get from that. Thanks for listening. As always, stay safe, and I hope to see you soon.